Hi everyone, here again I came back to you in order to show how to develop a structural equation modeling for a multinomial logistic regression with an example dataset. So the theoretical explanation of multinomial logistic regression in the case of structural equation modeling has been explained by the previous video. Now in this video I am going to show you how to draw or develop a structural equation modeling for a multinomial logistic regression having a multiple categorical outcome variable which is nominal in nature. So the models that we are going to draw will look like the one that you are looking over here. So the model finally that we are going to develop using the STATA window will look like this one. So I will going to show you how to develop this model using STATA. So I need to close this SEM builder interface and then I need to go step by step in order to just show you how to develop this model. So already I have a data set that have been taken from the STATA window, and actually I obtained this STATA data set from this STATA material from the STATA website. So you can download it by just going to there and by copying and pasting this link. So I have already the data set opened here in the STATA software. So as usual, let's go to statistics and then click on structural equation modeling and then click on model building and estimation. Okay, now here is the interface as usual that we are going to develop a structural equation modeling for any type of outcome variable. So since multinomial logistic regression is a generalized linear response category, that is a nonlinear outcome variable, we need to just make the GSEM active. The generalized structural equation modeling should be active. So I need to click over there. Click over here and then the GSEM syntax is already active now. So hereafter I am going to just draw a model. So first what I am going to draw is the outcome variable. This one, the type of insurance that we are going to predict with this given levels of predictor variables. So the type of insurance that is outcome variable should be drawn first. So to do that, I need to click over here, add observed variables, add observed variable set, because the type of insurance being indemnity, prepaid, and non-insured is directly measured by asking the individuals, So it is an observed type of outcome variable. But it is, since it is a multinomial categorical variable, we are using the GSEM syntax approach. So click over here, the add observed variables icon, and then just click the place where you want to put this outcome variable. So I need to click over here, and then here in this window what we are going to do is we need to select this box which says make variables generalized response. Generally, statistical models are just under two umbrellas, the general linear model and the generalized linear models. So the generalized linear models are those models which could model variables which are rather than continuous type in nature, and for those outcome variables which are not normally distributed. And actually this is another agenda or another issue. I will say something about generalized and general linear models in another video. But for the sake of this demonstration, since our outcome variable is categorical and nominal in nature, that is a generalized response variable. So we should make this active by just checking the make variables generalized response box by selecting over here. And then the family, that is a distribution family, and the link function should be selected over here. There are a number of distributional families and link function listed over here depending on the outcome variable, the type of the outcome variable. So we are going to select the multinomial logit model, which is around again Okay, here it is. The multinomial logit. So I need to select here. You see, after making this box, make variables generalized response, and selecting the family and the link function multinomial logit. So there are two boxes which are active above these two terms, you know. So hereafter I can select the outcome variable. The variable should be selected over here. The variable, the type of the outcome variable is the insurance, and then we need to select here. So after selecting this insurance, you see the labels will be inserted here automatically. 1B, 2, and 3. The first category of insurance will be labeled as the base category. And then the second and the third will be compared against the base one, the base or the first category. So there will be the second and the third type of insurance will be compared one by one against the baseline category, that means. So here it is the way how we can draw the outcome variable. So the orientation or the direction of this categorical type of outcome variable should be either vertical or horizontal. But for this case, I want to make it in the vertical way. So after selecting the vertical, I need to click on OK. So you see, here it is. So by holding the shift key and using the downward arrow, I can adjust the place where the outcome variable should be placed. Okay. Now, by deselecting this add observed variables, by clicking over there, the select or the arrow icon, I make it inactive. So that here is the outcome variable within the box. 1B insure. That means the first type of insurance is taken as the baseline, the reference category. The second type of insurance will be compared with the first category. This will be compared against this. And the third type of insurance, I think not insured category will be compared against this in terms of a number of predictor variables that we are going to draw. Okay, so what I'm going to do next is we need to add predictor variables. These predictor variables are listed here in the PowerPoint, you know. So I need to add a predictor variable age, being male. I have said before, 0 for female, 1 for male. So female is taken as the reference. So we can omit from the diagram, or even we can include if we do have enough number of space. Being non-white, 1 coded as 1, and other than non-white is coded as 0. So the 0 group of race is taken as a reference group. So the first or one code, the one coded as non-white will be compared against the 0 code. Okay, in terms of the geographical location or the site, the first site will be taken as a reference, and then the second, and then the second site. So we will draw these paths. So we need to add these predictor variables there in the STATA window, you know. So what we are going to do is we need to just add these predictor variables. Okay, since as you can see from here, all the predictor variables are again observed variables, observed type of variable. Age can be directly measured. Being male and female can be directly measured by asking or maybe from a certain record. Being non-white and white can be directly asked and measured. The site of or the geographical location of the study participants. Being in somewhere or a place where X and another place Y and another place could be Z. So this can be directly measured by asking the place where the individuals are placed. So since all these predictor variables are observed by their nature, so again I need to click on the icon which says add observed variables. Add observed variables. And I need to click the place where this variable should be placed. Over here, around here maybe. Okay. So now, what I am going to do is again, since the predictor variables are not multinomial in nature, I need to deactivate or deselect this box. The make variables generalized response should be deactivated because all the predictor variables are not multinomial. What was multinomial was only the outcome variable. So in this case, we need to uncheck the box which says make variables generalized response. So here again, the window will be changed in order to enable us to select the predictor variables from the list. So here I need to select age 1. Here I want to show you how can we include and omit the base category of the categorical predictor variables. So I will just show you how to include the base group of the categorical predictor variables in the model and how to omit the base category or the baseline reference group of the categorical predictor variables. So I will do just two times this procedure in order to show you how to include and how to omit the base category of the predictor variables. So now I have already selected age, which is continuous. It is not categorical. And the next is maybe being male and female, you know. Okay, being white and non-white. And the site. So male, non-white, and site are all categorical variables. So I want to show you how to include the baseline or the reference group for these variables. And then I will just go back again how to omit these baseline references. So just please give your attention while you are just looking the video in order to understand what I am telling you. Okay, so in order to add these categorical variables with their baseline reference group, I need to click there in the 3 dots over here. Click over here. Since categorical variables are named as factor variables, we need to select it, and then we are just going to specify or estimate the main effect of each predictor variable. So I need to just select the categorical variables list over here. The one is being male and female. So I need to select the variable male, and I need to select the base category over here, the reference category, whether it is being male or female. So let's make it female is a reference category, the first one. Because if male is coded as 1, that means 0, female is already 0. So after selecting this baseline, we need to click this add to var list. Add to var. Now it is added over here in the variable list. Okay. Next, what we are going to add is the non-white variable. Non-white. Again, we need to first the baseline, make it the first group should be a baseline. And then click on the add var list. Okay, now what is left is the site. The site, again, we should make the first category to be the baseline and click on add to var list. And then we have finished, click on OK. Hereafter, the final thing is the orientation of the variables. The direction of the variable. Could it be vertical or horizontal? Better to make it vertical in order to just have enough space over here. So now what I am going to do is I wanted to show you how to include the baseline groups for the categorical predictor variables in this procedure. So click on OK. Yeah. So by holding the shift key and using the downward arrow, we can just adjust the place where the predictors should be placed. So have a look at over here. Age is a continuous variable. And for the gender, the one which is coded as 0 is the baseline because B is attached over here. And male is the one which will be compared against this. On the effect of being male compared to female on the outcome variable, being in the non-insured group or being in the prepaid insurance type group. That is the essence or the idea. Okay, being white and non-white. Non-white, 0 category is taken as a reference because 0B, this B refers to the baseline. This is a comparison group against the non-white coded as 1. So this the one which is coded as 1 will be compared against with the 0 non-white group. The effect of this predictor variable or this specific category against this on being prepaid type of insurance or maybe non-insured type of insurance. Okay, in terms of the site, this first one is taken as a reference, and then the others will be compared against this, or to know the effect of these two categories on the type of the insurance. On the type of the insurance. So this is the way how we can include the baseline category of the predictor variables here, and even the baseline of the outcome variable also here. But we can omit the baselines, you know, if we know the categories that we made to be as a reference category. Okay, so because including all these baseline categories could make us to incur more space here in the window, you know, so the graph will be more complex. So in order to avoid that, we need to just omit them, the reference groups. So hereafter, I will just redraw the independent predictor variables again, just in order to omit the baseline or the base categories. Okay, so now delete, click on the delete. Okay, so I'm going to redraw again the predictor variables in order to omit the baseline. This is what I'm going to show you, you know, how to include and how to omit the baselines. Okay, so add the observed variables and click over here. And now make generalized response is inactive. So I need to select age 1, and hereafter just hit once the space bar, and then write 1.male. Only we are just telling the software to include the male group, which is coded as 1, the sex group as coded as 1. Then enter space once, hit space once, and then again write 1 dot non-white, non-white, non-white. Now, in this case, we are just including for these two variables by excluding the baseline for these two categories. For these two categorical variables, we are omitting the baseline, which were coded as 0, 0. Okay, since the site is having more than two categories, remembering this more than two categories might be difficult for us. So we need to include this with its baseline group, you know. So I need to go there in the 3 dots, click over the 3 dots and go to the next window. And then main effect is already there. And then we need to select the site variable here. And then we need to just add to var list. And then click OK. And then finally click OK. Okay, by holding the shift key and using the downward arrow, now you see the number of boxes are less compared to the previous one, because we have omitted the baseline reference groups for the predictor variables. Okay, that is really very interesting. And again, I'm just going to show, okay, I just place where the predictors should be placed by holding the shift key, and by using the left arrow, the downward arrow, the right side arrow, and the up arrow, we can just move. Okay, maybe somehow. Okay. So hereafter, I need to deselect the add observed icon. So I need to click over there, the arrow or the select icon. So what is left here, hereafter, we need to draw a path which connects the predictor variables with the multinomial outcome variable. The one which is indicated here in the PowerPoint, you know. Or maybe the one which is indicated in terms of textual words. So we need to draw a path from age to the second type of insurance. That means I need to click the add path icon here, add path, and then I need to draw from age to the second insurance. Why I should not draw a path from age to the first type of insurance is because this is the reference category of the outcome variable. We are going to compare this group against this, and we are going to compare the third type of insurance against the first type. So there is no need to draw a path to the baseline category of the outcome. Okay, so what is next is we need to draw again from being male to the second insurance, from here to here. And again, maybe from, okay, non-white for the two types of insurance, from non-white to the second type of insurance, from non-white to the third type of insurance. Okay. And again, the three sites to the third insurance. Okay, the baseline of the site to the insurance, the third type of insurance, and to again this one, the third site to the third type of insurance. Now we have finished our path draw and overall the model that we are going to that we want to draw or develop. You know, we can you can adjust the paths by just selecting and holding the cursor over there. Okay, maybe let's have just some adjustment like this and like this and then like this. Sorry, okay. Okay, so as you can see from the outcome variable box, there is a multinomial family and logit link function that we have selected previously. Okay, hereafter what is left is just estimation of the beta coefficients for each predictor variable on the multinomial outcome variable. So as usual, click on estimation and then click on estimate. Okay, nothing will do over here. Just simply click on OK. Okay, now the beta coefficients for each predictor variable has been displayed on the path, and by clicking over here we can see the details of the beta coefficients. The beta coefficients, the standard error, the z statistics, the p-value, whether it is statistically significant or not, the confidence interval for each. And we can just choose which types of results could be displayed over here, as I have shown you in the previous videos. You double click here by selecting all the paths, and by going to the appearance and the custom appearance, blah blah things, you can choose to put the beta coefficient with the confidence interval or with the p-value, whatever. And actually we can see within the STATA window the details of the results over here. You see, that means, for example, compared to the baseline insurance, that is maybe the indemnity type of insurance, being in the second type of insurance, the effect of age is this much, and actually not statistically significant. Okay, being male is statistically significant. Being non-white also statistically significant. And being in the third type of insurance, the effect of being non-white is actually non-significant for the third type of insurance. But the site here, you see, the site, because the first site was taken as a reference category, there's no result for the first site because it was labeled as B. That was a reference. So compared to being in the first site, the effect of the second site to be on the within the third type is this much, and it is statistically significant. Being in the third site or geographical location, again, not statistically significant. You see? So in this way, we can appreciate how a multinomial logistic regression could be developed in the structure equation modeling interface. Now, what we have displayed here is, you know, the beta coefficients. So we epidemiologists especially, or health professionals, are interested to interpret the results in terms of the odds ratio, or the relative risk, or the hazard ratio, or the incidence rate ratio. So I need to change these beta coefficients in the form of odds ratio. So what we are going to do is, either I need to go by clicking statistics over here, and then structural equation modeling, and then other, and then maybe, sorry, it is not over here, by going over the interface, click over here and then other, and report exponentiated coefficients. Okay. So click on estimation and go to others, and then we can click or select report exponentiated coefficients. Click over here and then click OK. And let's go to the STATA window again. And now the beta coefficients has been reported in the form of exponent of B. That is the odds ratio. So we can have a look at this. The result will be similar, statistical significant, non-significant, as before. But what will be different is we will interpret the beta coefficients in the form of the odds ratio. So this is a way how we can develop a structural equation modeling for multinomial logistic regression, and how we can estimate the beta coefficients, and how to report the odds ratio for this structural equation modeling multinomial logistic regression. So this is what I want to show you, and really it might be important for you. And those of you, please let me remind you to subscribe and to share for all others, because while you are subscribed, I could get a number of advanced features in the YouTube to add some additional links, to share again the materials, the data sets, the PowerPoints, whatever, for the followers of YouTube. And again, just to get you right notifications. So this is what I have for you today. Thank you very much for watching, and see you in next video.